Independence Day to all of you guys. Okay, so this is lecture 16 on numerical and graphical analysis. Okay, so I think we will start with the problems. We'll have the 2 minutes again. No rules are similar. 2 minutes we'll have. You can answer the problems. After that, I'll just do the problem. Okay, so should we start or not? Tell me, guys. Should I start now? Yes. Okay, so I'm starting it right now. Let us. Okay, question number one. Now, this is when you have the correct knowledge to try to do it fast because these are really good questions. A particle starts from rest. I'm repeating the question. A particle starts from rest. Its acceleration versus time graph is shown in the figure. The maximum speed of the particle will be. Now, who have given the answer? Okay, we'll see to that. What will the maximum speed of the particle will be? It is asking what is the maximum speed. Easy problem level 0 or level 1 you can say. I will say it to be level 1. Mainly it is a level 0 problem. Okay. 2 minutes for the question. Okay, I'll just share this link from YouTube to everyone. Just wait for 2 minutes. Any idea, Sparsa, Nitish, Radha and all? Darshan? Any idea about this question? Ahmad, any idea? Ahmad, can you solve this question? Okay, I'll try this question. Okay, let me try. 2 minutes are over. It's a really easy problem. Okay, so acceleration versus time graph. First, see how to solve a problem. First, go through what is given. Acceleration and time is given over here. Okay, so that means what you have to take first acceleration and time. You know that. Now, if you got first see the axes what they are representing, then go to the formula for them. So acceleration and time has one formula that it is equal to velocity by time. It is asking for maximum speed. That means what? Speed can be related with velocity. So I can relate acceleration is equal to velocity by time. I have told you now. If you write A is equal to B into C, then the graph of B into C. In the graph of B into C, if you calculate the area of graph B into C or B and C, then it is going to give you the value of A. Remember this rule, okay? And if it, let's suppose if I write A by B is equal to C, then if it is if it is in a multiplication form, then the area gives you the left hand side value. If it is in a division form, then your slope of this A and B graph will give you the value of C. Understood or not? So these two things you need to remember always. If it is in a multiplication, I'll get the area and I'll find the value of A. If it is in slope form, like if it is in division form, I'll calculate the slope and I'll calculate the value of C. Understood or not? Tell me this point. Are you able to understand this or not, guys? Yes or no? Everyone? Okay. So now, based upon this, try to see this. This is acceleration time graph. I can write velocity as acceleration into time. That means what? Area of acceleration time graph will give you maximum speed. Yes or no? So that area is going to be how much? What is the area of this graph? Perpendicular. Like it is a triangle over here. So perpendicular is how much? 10. Base is how much? 11. So you know that area of triangle is given as half into base into height. So that means what? This is equal to half. Base is how much? 11. Height is how much? 10. So 2 5s are 10. 11 5s are how much? 55 meter per second. Easy or not? Tell me yes or no. So apply this formula and you got the answer, that is 55 meter per second. Now there is one more point. Okay. Now, one more important point. Now, how to solve this? Like, if you want really, if you are not aware of like how to solve this, like you try to see this graph also. Acceleration is at maximum value 10 meter per second square. As the time increases, acceleration is decreasing with respect to time. Yes or no? So even acceleration is varying. So at that time, you can't apply normal formulas. So these formulas, v is equal to u plus at s is equal to ut plus half at square. All of this formula and this v square and u square, whatever it is, all the three equations of motions are only for constant acceleration. Remember that these are only for constant acceleration. Here what you observe from the acceleration time graph, that acceleration is decreasing with respect to time, means acceleration is itself varying with respect to time. At that time you can't apply this formula. That's why if many people will do what, they will think that acceleration is maximum, time is maximum, I'll apply v is equal to u plus at, and that will give you the answer, but that answer will be perfectly wrong. Understood or not? Are you able to get my point or not? So I'm telling you where you will do the mistake and where you can do the correctness. Correct or not? So please see, if you have given acceleration time graph, just stop for a little bit and then see whether the acceleration is constant or not. If it is constant, apply v is equal to u plus at or s is equal to ut plus half at square, or v square is equal to u square plus 2s. But if acceleration is varying with respect to time like this graph, or let's suppose this is acceleration, this is time, if it is increasing with respect to time like this graph, then only, like if it is increasing or decreasing, whatever it is, then only apply this formula, this aerial like area concept or slope concept. It will give you the correct answers. Understood or not? Can I move ahead? Okay, so moving to next question. Next question, question number 2. A lift is going up. The variation of the speed of the lift is given in the graph. What is the height to which the lift takes the passenger? It is a level 1 problem because still there are level 2, level 3. So it is a level 1 problem. Okay, think about this question. A lift is going up. So I'll just draw that little bit of, I will just try to make you imagine. Okay, you try to solve this. Okay. 2 minutes are going to get over fast. It's a really easy problem. Can anyone do it? Do it fast. Do it fast, yes. Ahmad, Nisant, Radha, Sneha, Sanjana. This person try to do it. Doesn't. You might be new to this class, but you try to solve this problem. This is really an interesting problem. This is a NEET question. Okay, NEET. I think 2013 or 14, when they used to give very hard questions of NEET. Okay. You don't think about this question. Okay. I'll do this. Wait. So look over here. Okay. It's 7:41 already. Yasmin, how much time you will take? Huh? Any idea about this question? Any logic if you want to give, you can speak to me. Okay. I want to see that whether you are little bit also understanding about the problem or not. Okay. Like what will be the logic also? You need to give it. Okay. Area. Think about it. Yes, area is. You try to think. Okay. Okay. I'll try to move ahead. So it's already over. 2 minutes are over. Okay. Now look over it. Lift is going upwards. So have you seen like movement of lift or not? First, it increases its velocity up to some time. Let's suppose in this time, it increases the velocity. Got it or not? Let's suppose if there is this lift want to go on the top floor. Okay, means here at this floor, this lift want to reach. So first it increases the velocity. Then what it does? Then it makes velocity constant for some time. Okay, at this part the velocity remains constant, but after that this part in this region what happens, velocity starts to decrease so as to stop the lift at this point, topmost point. Understood or not? So there are three cases. One, velocity is increasing with respect to time. After that, velocity becomes constant. After that, velocity is decreasing. So can I say that in this region, retardation is there? In this region, acceleration is zero. And in this region, acceleration is present. So three things. After that, one most important thing what we observe over here is like all of these velocities, the particular constant increasing, constant and decreasing are happening in the forward direction. They are all happening in the forward direction. So with respect to the retardation also, I'll get some displacement. With respect to the constant velocity also, I'll get some displacement. With respect to the constant acceleration also, I'll get some displacement. And you have to calculate this displacement. Now, how to calculate these displacements in an easy way? You know that velocity is equal to distance by time. So I can write distance as what? Velocity into time. So the area of velocity into time graph will give you the distance or not. Tell me yes or no. Everyone, guys, are you able to understand or not? Okay, so try to see this like in this graph, in first triangle, in this first triangle. Okay, what is the area? It is equal to half base, that is 2, into height, that is how much? 3.6. Now move ahead. When the velocity remains constant in this region, this is a rectangle, so I can calculate the area of the rectangle. This will be how much? 2 to 10. That means what, this length is how much? 8. Yeah, this length is 8 and this length is how much? 3.6 only. So this means what? This will become 8 into 3.6. Now see, in this reason, many people will think that this is a retardation case. So what they will do, instead of adding the displacement, they will decrease this displacement. Means try to see, this is region A, region B and region C. So total displacement I will write is as A plus B plus C. But many people will think what? That I should do like A plus B minus C. But that is perfectly incorrect. Why it is incorrect? Because your velocity is decreasing in the forward direction only. So the displacement is still positive. Word or not? I have done this kind of graphs for all of you guys. So for this reason A, B and C, what I am going to get? Now try to see for reason C. What is your velocity at this point? Like what is your displacement for region C? It is again equal to half into what is your base? 10 to 12, that means 2, and height is how much? Again 3.6. Multiply all of this, like you try to do this, all of this. So this is 2 got cancelled, that is 3.6, plus region B is how much? 8 into 3.6, that is 28.8, plus this D is how much? 2 got cancelled, that is 3.6. So total distance you got as how much? 36.0 meter. I think so. So option C is correct. Understood or not? Tell me everyone. Like what I'm trying to make you understand, this displacement, all of these displacements are in forward direction. So D1 plus D2 plus D3. That is the main reason. Okay. People will think that I need to do D1 plus D2 minus of D3. But you have to little bit think about the problem in a practical way over here. Understood or not? Yasmin, Radha, Darshan, Sneha, are you able to understand or not? Okay. After that, Sanjana, Sparsa, yes, Afan, Ahmad, okay or not? Yes or no? Okay. Now moving to next question. Question number third. Oh, wow, that is a really good question. A ball is thrown vertically upwards, then the velocity time graph will be a very good question. Means everywhere this question you will see it is a common question, but it is still a logical question. Okay. So level one is still. I'm still in level one. A very common question, but it is a really a nice question. I can tell you that. 2 minutes. 7:47. I'm counting still. Anyone? It's easy question. You have to think very, very fast in these kind of questions. Okay. Like you have to really be very fast. It's 48. 1 minute is over already. Okay, I'll discuss this. A ball is thrown vertically upward. So this is my ground. I throw one ball vertically upward. So I'll throw with the maximum velocity or not? Tell me yes or no. I'll throw with the maximum velocity. What is going to happen? This ball will go to, like, you know that in upward motion, what happens? The ball reaches some kind of maximum height. Okay. At this point, at the point of maximum height, ball stops over here. Ball stops over here. Its final velocity. This is my initial velocity and this is my final velocity. The velocity becomes zero at the maximum height. That means what? For total time of traveling in the upward motion, after time t, the velocity becomes zero. What you observe over here, that this velocity is zero due to one factor, that acceleration of the gravity is acting downward and it has a constant value that is equal to minus of g. But you try to see when the ball starts to come downward, here its initial velocity is still zero, but in the downward path within the same time frame, here, like at this point, its final velocity becomes v max. Yes or no? It becomes v max, which is equal to the velocity which you have thrown. So in downward path also, what you observe is still the acceleration remains same, and that is equal to minus of g, which is acting downwards. Now, if I want to draw, what I will draw? At time t is equal to 0, what I observe, I have thrown the ball with maximum velocity. At time t is equal to 0, I am throwing the ball with maximum velocity. After traveling time t, the velocity becomes 0. What you observe over here, since this retardation is a constant retardation, you got a graph like this. After time t, when the particle starts to do the downward motion, what you observe over here, that after time t, what is happening again? This time, this retardation is not there. This is an acceleration in the opposite direction. Now you know that how to draw the acceleration in the opposite direction. I have to go down. What you observe, that velocity is increasing in the opposite direction. So that means what? After time t, like in this time, the velocity is increasing in the opposite direction. Okay, with an acceleration of minus g. So this is the graph which I need to draw. Understood or not? Tell me yes or no. Got it? Everyone, are you able to understand this or not, guys? Yes or no? Sanjana as person, yes, Afan, Radha and all, Darshan. Is it okay or not? Tell me yes or no. Okay, so every time you have to think a little bit. Now, if many people will try to like in many graphs in the question, actually the options were like this way. Okay, means the velocity decreases like some kind of this way, like they have they gave. Okay, but is this graph correct? No, the answer is not. This graph is not correct. Why it is not correct? Because when I draw this graph, that means what? I'm taking the acceleration to be non-constant. Acceleration is non-uniform over here. But what you observe, that for first case, this is an retardation which is non-uniform. Uniform, this retardation is uniform, and in the downward case also the acceleration is uniform. So that's why you draw the graph like this way. So this graph, this kind of graphs and this kind of graphs are never possible. Okay, can I move ahead? So moving ahead to fourth question. Yeah, now this is level 2. I will say that this is level 2. You need to solve this. You need to think about this question. Think about this question first. Take your 2 minutes time. Level 2, take your 2 minutes time. Okay, maybe one first one. Not maybe. I need a sure shot. IIT or NEET is not a maybe question. Okay, first one. Yasmin's option is first one. Next, anyone else? Try to think about this question. This question is really good. Darshan, option one. Okay, Darshan is also saying option 1. So let us check into that. Okay. Now, what we observe, this is my displacement, this is my time. Now, what is displacement? What you observe over here, this is a graph of displacement with respect to time. Now, you know that what I have told. Let's suppose if you have y-axis, if you have x-axis, if I draw a downward parabola, what is the equation? Y is directly proportional to minus of x square. Yes or no? Y is directly proportional to minus of x square. That is the particular graph for downward parabola. Now, when we have what we observe over here, I can extend this graph like this way. I can make this down. So it is a perfect case of downward parabola that I am observing. So displacement is here directly proportional to minus t square. That is correct. First important thing. But after that, you see that there is a little bit rise, means between 0 to t, the values are positive over here. So how come values will become positive? We know that, like if I put t cube over here, like try to see like what variable you can put over here. You can't put over here t cube. Let's suppose if I put t cube, what is going to happen? The value will always become positive because this is powerful, much more powerful than t square over here. Okay. So if I take t is equal to 1 second, it will be 1 minus 1 0. If I take t equal to 2 second, displacement will be perfectly positive. But here the displacement is denoting like between 0 to 2 it is positive and after that it is becoming negative. So that means what if I take the higher power more than t square, this graph I'm not going to get. So that means what kind of graph I need to get? What kind of variable I need to put? So let us put a little bit less power. So if I put s is directly proportional to t minus of t square, what you observe over here? That let's suppose if I take t is equal to 0, I got displacement to be 0. That is correct. T is equal to 0, displacement is 0. Take displacement to be between, let's suppose now I am considering t is between 0 to 1. Like I take t is equal to 0.2 seconds. What you are going to observe that this displacement is how much? It is equal to 0.2 minus of 0.2 square. But you observe that this is 0.2 minus 0.04. Answer becomes positive over here. So it is correct. What we observe that in the region between 0 and 1, in the region between 0 and 1 second, the displacement is positive. After that, it is becoming negative. So I means you try to visualize this downward parabola can only rise up when you have a positive value added to it. And that positive value is added. Like try to see if I make a straight line over here, what is going to happen for this reason why this reason straight line is also negative, the graph becomes also negative, no problem. But for this reason there is a straight line in the upward direction and there is a curve in the downward direction. Definitely it is going to be possible that for some part this downward parabola will behave like a straight line and then it will properly use the it will use the factors of parabola. Understood or not? See, what I'm saying is, like, if you see the graph of, like, if you draw a graph, try to understand. If I draw a straight line, if I draw a parabola over here, so in this region, this is my y-axis, this is my x-axis. So in the negative region, in the negative x region, y is also negative, x is also negative. It is not a big problem. But in next region, in the first quadrant, what you observe that y is positive for x is equal to positive over here. For x is equal to positive, y is negative over here. For some reason, what will happen that this parabola behavior will deplete and the parabola will shift upward to follow the straight line equation. And after that reason, what is going to happen? The para will originally shift to this negative region. Understood or not? So there is a meaning in this graph. Okay. So here the most appropriate equation what we can get is displacement is directly proportional to t minus t square. Now you know that if I got the displacement equation from the graph, I can calculate the velocity easily. Like try to see that this displacement is dependent upon time. What will be your velocity equation? Velocity will be ds by dt. What you observe from this that ds by dt is how much? It is equal to 1 minus of twice t. What you observe that this velocity is directly proportional to time over here for an displacement time graph which is directly proportional to time square. Understood or not? You can observe from here. Mainly people in the how to solve this in a very easy way in less than 2 minutes. We know that this graph is of parabola, so displacement is directly proportional to t square. Now, since this is a downward parabola, so displacement will be minus of t square. Now, I can take ds by dt over here. This will be equal to minus of twice t. Now, we know that ds by dt is equal to velocity. Velocity is equal to minus of twice t. That means what? I will get a graph. Like if I see this graph, this is a positive graph. This is also a slope positive graph. This is never possible. So, what we observe here that slope is negative for this graph. Slope is negative for this graph, and this resembles, like try to see this velocity is negative, and that means what, the slope is negative, and here also slope is negative. So option 1 is correct. Got it or not? So using two ways you can think about this problem. You can either write the whole equation of displacement, like whole equation of this graph, or either in the simplest way you can try to think over it. Understood or not, everyone? Yasmin, Radha, Asparsa, Sanjana, are you able to get me or not? Darshan told correct. Afan, okay or not? Ahmad, okay? Ahmad, okay. Now, based upon this, I'll again increase your level. Now try to think about this question. Question number 5. Again, level 2. Think about this question. Previous question was very important. Got it or not? Means these questions, what I have assembled over here, you will not get in any kind of books or something like that. Okay. But you need to think about this kind of graphical analysis. Question number 5, acceleration time graph of the body as is shown below. Okay, the corresponding velocity time graph of the same body is. Now, who really understand acceleration time graph, then only it is possible. 3. Okay, one option I got, and I got it as 3. It is Darshan now. Okay, so Darshan has clicked option 3. Anyone else? Yes, ma'am. Think about this problem, Radha. Think, Asparsa, Sanjana, Sneha. Try to think about this problem. Afan and Ahmad. This is a really great problem. Okay. Okay. So I'll just make you understand. 2 minutes are over. It is a really easy question. 3 only. Okay. Yasmin also. Option 3. Let us check. Let us verify. Acceleration time graph. Again, I know acceleration here it is given the velocity time. So that means what, acceleration is equal to velocity by time. We know that velocity is equal to acceleration into time. That is correct. I got my point over here that for velocity is equal to acceleration into time I have to draw. But try to see. For 0 to t means this is 0. This is some kind of time t. What is happening? Acceleration remains constant. If acceleration remains constant, what will happen? This velocity, try to understand this graph perfectly. If acceleration is constant, you need to keep into mind this property. What is going to happen? Velocity increases uniformly. How many times I'll have to tell you? I'll not have to tell you many times. If acceleration is constant, velocity increases uniformly. If velocity increases uniformly, the graph will be what? The graph of velocity time graph will be what? It will be perfectly linear. Yes or no? So what is happening? If the acceleration is constant, I got my velocity time graph to be increasing over here. Understood or not? Linear graph. After that, for t to some kind of t prime, what is happening? Acceleration is 0. Next case, for t to t prime, what is happening? Acceleration is nothing but it is equal to 0. Now, if acceleration is 0 at that time, that means what? Velocity is constant, not velocity is 0. Many people will think that velocity is 0, but velocity remains constant over here. Okay. So if you try to understand this, if this acceleration graph from here, it would happen like you try to see wherever if you see in acceleration time graph, if the acceleration remains constant, velocity increases. If the acceleration becomes 0 after some time of traveling, that means what, velocity is constant over there. So for some time t2 t prime, I got my velocity to be constant again. Okay. After that, again see from t prime to some kind of t, again t double prime, what is happening? Again there is a constant acceleration. That means what, many people will think that the like 2 to t prime acceleration becomes 0, and from t to t prime to double t prime acceleration again becomes positive. So many people will think that it is a case of retardation, not the case of different thing, not the case of acceleration. Okay. So in the viewpoint of it, like 98% of the guys will take option 1 correct. Why? They will think that first acceleration is increasing, okay, velocity increases. Second, acceleration becomes constant, 0, velocity remains constant. After that, again t prime to double t prime, acceleration is positive. Try to see that acceleration is constant in positive path. Okay. So therefore that means what? Velocity increases after that. Okay. not decreases. Got it or not? So velocity increases after that, since acceleration is positive and it is also a constant term. So that means what? Velocity will again increase from t to t prime to t double prime. What is going to again happen? Velocity increases further, not decreases. Okay, but if the similar graph, I'm saying you, if this okay, wait, if in the similar graph, if in the similar acceleration time graph, okay, I'll show this is my acceleration time graph, okay, and it is remaining constant. After that, if this kind of graph I would have got acceleration time graph, then you know that for this case, since after time t prime to t double prime, acceleration is becoming negative, so that means what? The velocity should have decreased. So for this acceleration time graph, option 1 is correct. For this acceleration time graph, option 3 is correct. Understood or not? Tell me so no. Guys, are you able to understand or not? Everyone? Radha, Sparsha, Sneha, Yasmin, Darshan, are you able to get me? Ahmad? Yes or no? Afan? Okay or not? Understood. So this is the main conclusive point over here. Okay. So you have to little bit think, just a little bit wait and watch about the question. Okay. Move to the next question. Question number 6. Which of these represent a uniformly accelerated motion? A and yeah, correct. Fast. Yeah, be fast. It is correct. Uniformly accelerated motion. Like uniformly, it is saying that means what? Acceleration should also what? Oh, okay, wait. I'll ask this question. What does uniformly accelerated motion means? Tell me, everyone. Acceleration should increase or not? Tell me. Hmm. Yes. Hmm. Yes, Asmin. Constant acceleration. What you said? Constant acceleration. Motion is accelerated means the body accelerates. Okay, with a constant a value means the velocity is going to increase, but it should not decrease. Okay, and velocity should increase in a non-uniform way. Got it or not? Wait. In a uniform way. Sorry. If I talk about uniformly accelerated motion, what remains constant? A remains constant. That means what? V increases in a linear way. V increases uniformly. Okay. But if V increases uniformly, that does not implies that displacement will increase. So if V is increasing, that means what? Displacement or distance is unequal in equal interval of time. In equal interval of time. So if your acceleration is constant, you know that velocity is going to increase uniformly. So how to verify that? So look over here, draw the slopes, select the points in this displacement time graphs, draw the tangents over there. Here, select the points P, draw the tangents over there. Okay, at this point P, draw the tangents over there. At this ST limit. Okay, so what you observe that in first equation the tangents are pointing upwards. That means what? What is happening? Right angle triangles are the sizes of right angle triangles are increasing. That means what? Velocity is increasing. Okay, second case, what happens? Similar triangles you are going to get. That means what? Velocity is constant, because tangents mean slope. Calculating, like, try to see this. If I draw the tangent, I'm actually drawing the slope. In first case, the slope is increasing. That means V increases. Here, slope is constant. That means what? Velocity is constant. Here, slope. Try to see that triangle sizes are decreasing. That means what? Slope is decreasing. Slope decreases means what? Velocity decreases over here. Velocity decreases over here. So in which case velocity increases uniformly? So in first case velocity is increasing. Now if velocity is increasing, A remains constant. So option 1 is correct. Understood or not? Tell me yes or no. Got it? Everyone? Sana, Radha, Ahmad, okay or not? Darshan, okay? Afan? Hello. Mm-hmm. Tell me your phone. Are you able to get this or not? Okay. Hmm. Okay. Let us move to new point. Question number 7. I'll repeat this question. A ball is dropped vertically from a height h above the ground. It hits the ground and bounces up vertically to a height of h by 2. Okay. Neglecting subsequent motion and air resistance, its velocity v varies with the height h as. It's really a good question. JEE level 3 question. Okay. Level 2 only. Put it to level 2 because this is of JEE mains. JEE mains 2014. It's a really nice question. A ball is dropped vertically from a height h above the ground. It hits the ground and bounces up vertically to a height h by 2. Neglecting subsequent motion and air resistance, its velocity varies with respect to height. Velocity with respect to height. First one. Why not third one? G remains constant, Yasmin. Yasmin, it is now. Yeah. Tell me. First one, right? Not the matter of greatness. I am telling acceleration due to gravity remains always constant. So how come first one will be possible? It is a non-uniform graph. Try to see velocity is varying non-uniformly with respect to height. But actually acceleration remains constant or not with respect to height. Which thing relates velocity and height? Which thing relates? First think about that. Velocity and height is related by which formula? Yes, fine. I got you. Yes, fine. And this is where, see, if you are giving the correct answer, answer is correct. First one is correct. But you need to know why it is happening. Okay. So there is a reason for everything. You have to tell why it is happening. Got it or not, guys? So I have always, so what is happening? Ball is dropped. A ball is there. It is dropped from some kind of height h. Okay. At this point, it has initial velocity to be equal to 0. At the point after covering height h, it has the, here you have the maximum velocity. With this maximum velocity, again it is thrown upwards. It travels h by 2 and stops over here. Here u becomes like final velocity for this in the upward path. This becomes 0 over here. Understood? Now this is my whole condition over here. Okay. In this condition, what you observe that acceleration is minus z, acceleration is equal to minus z. But I told this thing to confuse you. This acceleration, which is equal to constant, it is constant with respect to time. It is not constant with respect to the height. Understood or not? Remember that acceleration always varies with respect to height. It remains always constant with respect to time. Understood or not? So here what is happening, try to see this acceleration of minus z which we have calculated, it is only calculated with respect to constant time, like with respect to the variation with respect to time equation, not with the variation with respect to height. Try to see that. I can write acceleration as what? Acceleration is what? dv by dt. I know now, everyone. Acceleration is what? dv by dt. I can write this as dv by dx into dx by dt. Now we know that dx by dt is velocity which is varying with respect to time. And this is my velocity which is varying with respect to position. So remember that if your velocity varies with respect to position, acceleration does not remains constant. So this graph is not possible. Okay. So look over here. If this velocity varies with respect to position, your acceleration can never be a constant term. Understood or not? So acceleration will also start varying with respect to position. So this graph is not possible over here because velocity into displacement graph is somehow is related to acceleration. Understood? So this graph is not possible. Move to next case. What you observe, initially your initial velocity was 0 after traveling the displacement h. Now it is saying that take vertically upward direction as positive. If I'm moving in the downward direction, this h will become negative. So for negative h, what is happening? Velocity becomes maximum at the like after traveling this minus of h. Now we know that, like if I just do the opposite thing, that means what? Velocity is maximum u is equal to v max over here. For positive x, final velocity is becoming 0 over here. So look over here. For if I just draw this, if I think this thing in opposite way, like the whole motion of the downward path, what is going to happen? That at t is equal to 0, at displacement is equal to 0, I'm having the maximum velocity. Okay, and I throw this upwards, I throw this ball upwards, I'm throwing this ball upwards. What is happening when it is traveling displacement h after time t at the maximum height? What is happening? Velocity becomes 0. So after traveling the maximum height, velocity at here, that is h max, and that is here, velocity is becoming 0. Are you able to understand me or not? Tell me yes or no. Up to this point, is it? Are you guys able to understand or not? Radha, Sparsa, yes or no? Ofan? Okay, Yasmin, Sanjana, okay, Ahmad, okay or not? No. Till now it is correct. Now try to think the downward path in the similar way. Okay, means try to change this. Okay. Now what is happening? Here you have the similar velocity maximum. Okay. What is happening? What you observe over here, that after when it is traveling h by 2, its velocity is becoming 0 again. Yes or no? So its velocity is becoming 0 after traveling how much distance? H by 2 distance. So at this height, since your velocity becomes 0 after traveling how much distance? H by 2 over here, what is happening? Your velocity is again becoming 0 at this point. Now, what I observe that in downward path, now this is a very good thing. You try to see that in the downward path, what I'm saying is, like at this point, when the particle starts from here, what is happening? Its velocity is maximum, okay, and here its velocity is 0. So, like when it is traveling in the downward path, what is happening? Somewhere it has minus of v max. Okay, after that, this velocity starts to go to 0 when the particle travels from h to h by 2. Understood or not? Now, many people will think that option 3 is correct because since this is a similar resemblance, okay, velocity was maximum at like initial point. After that, when the displacement becomes 0, when it falls on the ground, velocity is maximum. Okay, now when it travels like similar distance in the opposite direction, the velocity approaches 0. It becomes 0 over here. Now, what they will think that in this path, since the acceleration is a constant term, acceleration is equal to minus of g, they will take option 3 as correct answer. But this is not correct. Why? Because when you get velocity into displacement graph, the acceleration actually have the equation. It is equal to v into dv by dx. It is not equal to v dv by dt. So that I can understand. Okay. So when it is written as v into dv by dx, if your velocity changes with respect to path, acceleration also changes at that time, and acceleration does not remain constant over there. Understood or not? Tell me yes or no. Guys, are you able to understand this question or not? Yes, sir. Radha, Afan, okay. Ahmad, Sneha, okay or not? Okay. Sanjana, Sparsa, Yasmin, okay. That's an okay or not? Tell me. Yes or no? So this was the main reason. Okay. Now I will give you one task. Okay. Now you try to think that this graph should have been drawn till here because the motion is from h to h by 2. Why I am drawing this much of the graph? It will be your work to see. Okay. It's not discussed in any kind of video, but people will do like this. Okay. They will just draw it. But you need to think why for h is equal to 0 only I am considering minus of Vmax. I want to see means for displacement 0, why you are considering minus of Vmax. I need that answer. Okay, and that will be your topic for next class. Okay, so this graph, the resemblance of this graph, I want to answer. I need to know. Then only you can try to solve some more questions on that. Okay, so these are still there are many questions, and there are see this J mains and J advanced. What kind of questions these are? Okay, so all of these you need to discuss until unless I will discuss only and only when you do this problem. Okay, that why sir has taken this extra graph over here. Okay, if you answer this, then it is correct. Then I will try to do it. Okay, understood or not? What do you know your homework or not? Huh? Okay. Okay, so YouTube families also, please try to think why we have drawn till over there. It will be your work to do it. Okay. If you reply me in a correct way, then I'm going to delete it tomorrow. Okay. So tomorrow a question starts from here and little bit of relative speed. Okay. When I'll do a little bit of relative speed, please try to say it. So first tomorrow I'm going to do relative speed. Okay. Because all the equations of motions and all are complete. After that, I'll solve these graphical problems. Okay. So half an hour of topic, half an hour of numerical problem. Understood or not? Everyone? Okay.